Hello guys, my name is Aditya, and today we are going to solve this problem. So here we have a digital signal where either 1 or 0 is transmitted through noisy channel, and then we receive data from the signal sent. Okay, um, so there's a probability of each signal being transmitted. So for 0, the probability is 0.6, and for 1 it is 0.4. Okay, so now when we are sending it to the channel, the probability of 0 going as 0 is 0.7, and it is received as 0 is 0.7, and 0 received as 1 through the noise would be 0.3, whereas 1 going as 1 is 0.8, 1 going as 0 is 0.2. So you have to find out two things here. First, the probability that the data 0 is received. Second thing is probability of error, that is when we transmit 1 but receive 0, and we transmit 0 but receive 1. Okay, so first things first, let's solve the first question. We have to find the probability of 0 received. 0 received. So this is simple, so right. So probability of 0 received. So we have two cases here, right? Either we send 0 and receive 0, right? That is the first case. And the second case would be we send 1 and there's some noise in the channel and we receive 0. So it's an OR case, right? So there would be an addition for sure. So first we start with we send 0 and receive 0. So the probability of transmitting 0 would be 0.6. Then we received it, so this is 0.7, so into 0.7, or we sent 1, so transmitting 1 is 0.4 and receiving it through error is 0.2. So this is just basic maths, so it's 0.42 plus 0.08, so this comes out to 0.5. okay, so we solved the first problem. Now the second one is the probability of error, so let's do that one. Okay, for probability of error, we're going to use the same thing where same logic actually. So probability of error, so when we transmit 1 we receive 0, or when we transfer 0 and we receive 1. So probability of, so in both cases it's OR, right? So here we're gonna add both the cases too, so similar logic. So the probability of transmitting 1 is 0.4, and receiving it through noise is 0.2. okay, and probability of sending 0 is 0.6, and receiving it as 1 is 0.3, right? So basic, so this is coming out to be 0.08 plus 0.18, which turns out to be 0.26, which is the probability of error. So this was the answer to the third question, and thank you so much for listening.